Is it a proportion or a mean?
Mean.
How do you know it's a mean?
Average. Standard deviation.
Yep. It has the words average and standard deviation. Is it a hypothesis test or a confidence interval?
Hypothesis test.
How do you know?
Enough evidence to reject the claim.
Yeah, there's evidence and there's a claim. Everybody good with that? And there's a question as well. And also there's no confidence interval or estimate anywhere. How many samples?
One.
One sample. All right, so which function am I going to use?
T-test.
Whenever it's a mean, remember mean Mr. T? Means will always start with T. Proportions will always start with proportion. Does that make sense for folks? A test will always end with test. A confidence interval will always end with interval. Good. And then if it's two samples, it'll always start with two. So that's kind of how you work these out. So it's a one sample is a mean, so it's going to start with T. It's a test, it's going to end with test, so it's a T-test. So everybody go ahead and do this one. Value, I want 2 decimal places, and the p-value, I want 4. Yeah. Or 3 sig figs, sorry, 3 sig figs at least.
Yeah, because in the homework,
Yeah.
I think it's 3.
Yeah, 3 sig figs is good.
That's just 3 numbers, right? For 3 sig figs?
Yeah. 3, yeah, but not counting zeros.
Oh, so okay.
So the T-test would be, what is my mu naught? 8. So remember, your mu naught is always what's in your claim. So our claim is the average is 8. So my claim is that mu is equal to 8. So my mu naught is always whatever number is in my claim. It has nothing to do with your sample at all. It's always, you grab it from the claim. For a regular one like this, one sample, it'll be the number in the claim. For the 2 samples, especially the 2 sample dependent, that's the time when you're looking at the differences. So this would be 0, only in that 2 samples. One sample, it's going to be that number. Okay, good. So then they ask you for X bar 8.2. They ask you for S 0.6 and N 32, and they ask you for the symbol.
It's going to be the opposite one.
Yep.
Not equal to.
Not equal to, exactly. When your claim is equals, H will be not equals. And then you ended up with a T value of
1.89.
and a P value of
0.068.
687. Sounds great. Good. Next. Connor, go ahead and read.
Researcher wishes to be 95% confident that their estimate of the true proportion of individuals who travel overseas is within 4% of the true proportion. Find the sample necessary if, in a prior study, a sample of 200 people showed that 40 traveled overseas last year. If no estimate of the sample proportion is available, how large should the sample be?
Perfect. All right, take 30 seconds with your neighbors. What kind of problem is this? So folks said proportion. Why is it a proportion?
It says proportion.
It says proportion. And then people also said confidence interval. Yes? No? Or is it a hypothesis test?
Confidence.
I do.
Which one? Okay. So in a sense, it goes along with what? It's under the confidence interval area. Why? Jason, why did you say confidence interval?
It says
It says estimate. Is that, everyone see that? But Sean had his hand up. Why does Sean have his hand up?
I was going to say it's because we're trying to find N with the
Yep.
confidence interval.
It's a confidence interval with a question or with a statement. So, so let's say I had removed this part here. Let's pull this out for a second. If we pull this out, then this could be a problem. This could be the thing. And I just try to find a confidence interval. What would I use? I would do what kind of, so I need to have my confidence level. I need to have my p hat. I need to have my n, correct? To do a confidence interval? Where's my n here?
There is no N.
There is no n. Does everyone see that?
Yes.
So there's no n. how could you possibly find a confidence interval? That's because we're asking you to, like Sean and Connor were talking about, how large should the sample be? A lot of you folks start picking up on that and saying, hey, wait a second, how large should it be? That really means, what is n? So this is a find n problem. It's in your yellow sheet. What's the formula for that? Find it.
N equals p hat q, then this critical value divided by the error.
And it's squared, right?
Squared.
Exactly. All right. So for this one, a couple things. So first off, what is my critical value? So you will need the z table for this one, but this particular one, 95% confidence interval, you all know that critical value. It is 1.96 exactly. And then no estimate of proportions are available. What shall I use for p hat and q hat if I have no estimate?
50-50.
50-50. 0.5, 0.5. So then that gives me these pieces, but if I'm trying to find n, I have to give you e. So e must be in this problem somewhere.
Within 4%.
Within 4%, exactly. Because the guy says, I will guess your age within 3 years. He gets 3 years this way, 3 years that way. That's his error. You find the word within 3 years. You find the word within, that's your error. So error is either going to be called error. It'll literally say the error is, or it'll say within. Within is sort of the disguised way of saying what the error is. So your error is 4%. You see it right here. Right. In 4%. My error is 4%. So everybody go ahead and find this. Yeah, I can do that right about.
Not this.
I'll do those second, sort that yourself. So again, p hat and q hat, if you don't know what they are, you use 50-50 for those, so those are all 0.5. And then your critical value for a 95% confidence interval for a proportion is 1.96. And we said our error is 4%. That is not.
0.4. It's 0.04.
Okay, so is that, if I do this, am I okay?
No.
No.
No, because remember, 4% is 4 cents, not 400. So that would be, is this right?
No.
No.
Would be
Gotta add a 0.
Got to add another 0. It's 4 cents, 0.04. Okay, good. And y'all got 600.25.
Yep.
Now, can I ask 600.25 people?
No.
No. So, if you look at your formula on your formula sheet, it says minimum sample size. Does everyone see that?
Mm-hmm.
Because it's the minimum, I cannot make it 600. I need 600.25. That is the minimum I need. So this is the only time this entire class that you're going to round up to 601. Because this is a minimum. So if I go in and buy something for $600.25, I cannot give them $600. I have to give them $601 because this is the minimum I need. Everybody okay with that part?
Yep.
Okay, so this, again, this is the only time you round up is when it's minimum sample size, when you're finding n. So that is 601. Okay, let's take a look at this one. So here's one where there is an estimate that they're giving us. So we still need to find the sample necessary. Oops. But we're using the information that in a prior study, out of 200 people, 40 traveled overseas. So remember with the proportion, you're always going to be given n, and you're either going to be given x or p hat. Is that x, is 40 x or p hat?
X.
How do I know it's x and not p hat?
It's not a percentage.
It's not a percentage. It's a whole number. So it means I need to find p hat. So what is my p hat? And if you're not sure, then
40 over 200.
Yep.
Yeah. It would be
it's
0.2.
x over n, 40 out of 200. 0.2. So then you need to find your q hat
Would be
and then
48.
compute this one. So I want to do this. I'll give you folks a minute for that, and then we'll go over it. So because 0 is not included, or mu naught is not included, then we would reject h naught if the corresponding hypothesis test. All right, so as I was saying, since 0 is not contained in here, then it's entirely negative. It does not include 0, does not include a mu naught. This would have rejected the null hypothesis. I was talking to a colleague earlier today. I think she's in either in the sociology or psychology department, and she was saying that there's actually a trend there to start looking more at confidence intervals instead of hypothesis tests, because confidence intervals kind of give you the same information as a hypothesis test, right? You would say, oh, it doesn't include mu naught, so then you would reject the null hypothesis. It really is different, but it also gives you a sense of exactly where the values should lie. So it kind of gives you a little more information in many ways. All right, let's take a look at the next one. All right, Sean, go ahead and read this one.
Researchers want to test a new anti-hunger weight loss pill. They have 10 people rate the hunger both before and after taking the pill. Does the pill do anything? Use alpha equals 0.05.
Great. Take 30 seconds with your neighbors and figure out what kind of problem this one is. All right, so is this one a mean or a proportion?
Me.
How do you know it's a mean?
Yeah, numbers.
Because my data is numbers. Right, so there is not the words mean or average or standard deviation in there, but this is the mean in disguise. My data, there's my data, it's in numbers. Is it a confidence interval or a hypothesis test?
Hypothesis test.
How do you know it's a hypothesis test?
It doesn't say anything about it.
Right, it does not say, there's no estimate or confidence interval in it. Why is this not working right? Estimate or confidence interval. All right, how many samples is it?
Well, it's technically 2, but it's going to be 1 because it's a dependent one.
Yeah, so there's 2 samples, and they are means. So 2 sample means, are they, don't say it, but think, are they independent or dependent?
Sorry.
What was that? Okay, and what do you folks come up with?
Is it dependent?
This one is the dependent. They're in matched pairs. Everyone see that? So, all right, so go ahead and do this test. I'll give you folks a couple minutes to come up with the p-value and the test stat. So this is 2 samples means, and they are dependent, we said. So that means that you need to subtract them. All right, remember the dependent ones, we subtract these. And then it's no longer 2 samples, like what I was saying earlier. It becomes just 1 sample of the differences, which also means that we no longer use mu1 and mu2, we use mu d. Yeah, so then we'd be looking at mu d is equal to 0, would be our h0. So in the calculator, someone said, well, wait, Ms. Young, what if I put them in the wrong spots? What if I put my group 1 into list 1 and I put my group 2 into list 2? Has anybody made this mistake before? Mm-hmm. What you do is, you have to retype them in list 3, so you can't do this in list 2 first because you'll overwrite list 2. But in list 3 where it's empty, go up so that you're actually on the L3, and then type in L2, second 2, hit enter, and let's copy over whatever's in L2 will go into L3. And then I need my L2 to be L1, so I'll go up to L2 and do second L1. Remember, you can't do that one first, because if you did that one, then you'd overwrite L2 and you'd lose that whole all the data you typed in there, you have to type it in again. And then in L1, you're going to go up to L1, and again, your cursor has to be on the L1. You can't do it here. If I did it right here, if I did L2 minus L3 here, where my cursor is just in L1, I get an error. You have to do it when cursor's actually on the L1 itself. Second L2 minus second L3, and then bam, it subtracts them for you. Then you can go to stat, test, t-test, and again, and then you're going to pick data, because I have data here, and this time your mu naught's going to be 0, not 8 like it was previously, right, for one sample, because we're saying when we have 2 samples, their differences are 0. That's our h naught. So is that what mu1 equals mu2, or in other words, the difference mu d is 0. Only for 2 samples. One sample, it's going to be a number, like it was 8 last time, or 53.6, or whatever it's supposed to be. All right, and then L1, 1, frequency 1. You only want 1 of each, so leave your frequency at 1. And then my claim was not equal to, so I'm going to go to calculate, and I got a p-value of 3.597, and a p-value of 0.00577. So folks been good about that? Right, a couple more just real quick. Chris, go ahead and read.
Through consumption, a nutritionist found that in a random sample of 80 families, 25% indicated that they ate fruit at least 3 times a week. Find the 99% confidence interval of the true proportion of families who said that they ate fruit at least 3 times a week.
Great. Is this a proportion or a mean, folks?
Proportion.
Proportion. How do you know? Does it say mean or average?
Percentage of the wall.
It has a percentage. Is it a confidence interval or a hypothesis test?
Confidence interval.
Confidence interval. Okay. Find it. Find it quickly. So it's one sample is a proportion, so it should be one proportion. It should end in interval. Yep, Z interval. And it wants me to put in, take a look at it.
What's your p hat not 0.25 in that case? It should match up with the 25%.
And it says, what's my x? Oh, what's my x? Is my x 0.25?
No.
No.
Is my x 3? No.
No, you would have to multiply.
So again, I'm always given n. What's my n?
80.
80. And then I'm either given p hat or x. 25%, is that p hat or is that x?
Yeah.
It's p hat. We have to find x. How do we do that? On your yellow sheet, under the very, very bottom corner back here, it talks about if x is not given, use x equals n times p and round to the nearest whole number. You don't round up, you round to the nearest whole number. So you round correctly for this one. So here my n is equal
Yeah.
to, I'm sorry, my x is equal to np.
Oh, did you get this one?
80 times 0.25, oops. 80 times 0.25 or 20. So you put in 20, comma, 80, comma, confidence level 0.99. And I got 0.125 to 0.375.
Yep.
Okay. Female gun owners.
Oh, Gallup poll.
Mm-hmm. Oh, we're changing this to 118.
What?
118. Okay. Austin, go read.
Gallup crime survey stated that 23% of gun owners are women. A researcher believes that in the area where he lives, less than 23% are women. He randomly selects a sample of 118 gun owners and finds that 11% of the gun owners are women. Test the claim at alpha equals 0.01.
Great. Okay. Is this a mean or proportion?
Proportion.
Proportion. Is a hypothesis test or a confidence interval?
Hypothesis.
Yep. Testing claim. Hypothesis test. Okay. How many samples? Just one. Okay, so what's my claim?
In Gallup polls stated that
He
no,
believes
less than 23.
less than 23%. So is it P or is it
P.
Okay, so he believes that P is less than 23%. And again, we're using a sample size of 118. All right, go ahead and find our test statistic and our p-value. All right, so remember, we can't just put in 11%. That's what test we're doing. We're doing, it's a proportion, so we're doing one proportion. And it's a test, so yeah, z-test. They want our p-naught. P-naught is whatever's in the claim. So 23%, 0.23. And then they want x. If anybody put in 0.11, you're going to get in big trouble because that is not, how do you get 0.11 of a person? That's not even a whole person. That's like what, like, you know, maybe like their arm? You're going to get an error. You cannot ask 0.11 of a person. You have to figure out how many people this is. So remember, we're always giving you n, sample size of 118, and then 11% is not your x, it's your p hat. How do you know it's p hat and not x? Because it's a percentage, yeah. So you have to figure out what your x is. So you would do x equals 118 times 0.11, and you get 13, is it 13.2?
12.9.
Yeah.
12.8?
12.98.
12.98.
And then round to 13.
Oh, we rounded it to 13.
Yeah, it has to be, so it has to be 13, because you cannot ask a fraction of a person. You have to use a whole number. Anyway, 118, and my claim, my symbol was less than. So you ended up with a z-score of
Negative 3.093.
3 point what?
0.93.
0.93?
Yeah.
Yeah.
Okay. And a p-value of
0.99.
the other way.
What?
You put greater than. Yeah, if you put greater than, you get the
I
opposite.
messed it up.
That's okay, no worries.
9.90.
I'm sorry? Oh,
Oh wait,
right. Give me that. 9 point what?
903.
9.903?
E negative.
Yeah,
E
hold
negative
on.
4.
We're going to get to in a minute. All right, so 990%. Remember, we can't, anytime this is larger than 1 or 100%, their drama better be an E negative at the end. And this one is E negative 4, folks. Is that what folks said?
Yeah.
So again, E negative 4 means you move the decimal place over 4 times to make it smaller. The shortcut to that is E negative 4 is 4 zeros. And then your 990. And you put the decimal place after the first 0. Good. Anytime this is like E negative 6 or less, I want you to go ahead and write it out. If it's E negative 16, just leave it as negative 16. I don't want you to write 16 zeros. That's unreasonable. But But yeah, 6 or less, you know, if it's 7 or more, then you can just write E negative 4 or whatever, 7 or whatever it is. All right, good, good. This one, take a look with your neighbors, decide if it is a mean or proportion, a hypothesis test or a confidence interval, and how many samples we have.